Hi guys, welcome to a new video on differentiation under math studies, paper 2. In this video I shall tackle these two questions. They are of advanced level difficulty, and I shall begin question 1 shortly. I shall now solve paper 2 November 2001 question 8I. Kindly take a minute, attempt to solve, and the answer shall follow through shortly. So, the curve y equals f of x has its only local minimum value at x equals a and its only local maximum value at x equals b. If a is less than 0 and b is greater than 0, sketch a possible curve of y equals f of x, indicating clearly a comma f of a and b comma f of b. So we need to provide a sketch where at x equals a there is a minimum point and at x equals b there is a maximum point, knowing that a lies on the negative x-axis whereas b lies on the positive y-axis. So your curve should look something like this, where a is in the negative and b is in the positive x-axis, and a comma f of a is a minimum point and b comma f of b is a maximum point. In question B, you are told, given that 0 less than h less than 1 and b minus a is greater than 1, are the following statements about the curve y equals f of x true or false? So b minus a is greater than 1 means that the distance between these 2 points, it has to be greater than 1. And 0 less than h less than 1 obviously means that h is less than 1. So watch out. So whenever I get something like f of a plus h, they want to tell you that since h is less than 1, h will never be after b. Because we said that b is further away from a than 1. b minus a is greater than 1. So b is far away from a. Whereas h is less than 1. So h has to be closer to a than b. This is the point of the inequalities provided here. Now, so f of a plus h is less than f of a. What do you think? If h is somewhere here between a and b, is f of a plus h greater or less than f of a? Obviously, greater than f of a. Simply because the function is increasing. Hence, question I is false. So in double I, f dash of b minus h is positive. So where is f dash of b minus h? H, we said, is somewhere between a and b. So I want the f dash of a point anywhere from here to there. So let's take this point for example. Is the slope positive or negative? Since the function is increasing, hence the slope is positive. What about there? Also, since the function is increasing, the slope is positive. So anywhere between a and b, since the function is increasing, the slope is positive. So this is true. Triple I says the tangent to the curve at the point a comma f of a is parallel to the vertical axis. So the tangent to the curve at point A is something that looks like this. Is this parallel to the vertical or to the horizontal axis? Obviously this is parallel to the horizontal axis. So triple I is false. IV says the gradient of the tangent to the curve at point A comma f of a is equal to 0. So again, let's draw the tangent at a f of a. Since the line is horizontal, hence the slope is 0. So this is true. The tangent has 0 gradient. So IV is true. Question V says f of a minus h less than f of a less than f of a plus h. So where is f of a minus h and where is f of a plus h? Since h is the same, if f of a minus h is somewhere here, f of a plus h will be somewhere there. And you can notice, due to the symmetry of the curve, that they shall always be equal. Hence, v is false because they are not less than, they are equal. F of a minus h is equal to f of a plus h. Vi has to do with points of inflection, and that does not concern us. So there are your answers. Take a minute to copy them down if you will, and this concludes this question. I shall now attempt to solve May 17, time zone 2, question 6. Kindly take a minute and attempt to solve, and the answer shall follow through shortly. So you are given a function f of x, but you have one missing term represented by a instead of a number. So anyway, in question A, you are required to write down the y-intercept of the graph. So the y-intercept, which is right there, exists at the point where x equals 0. So it's the point on the y-axis where x equals 0. So to get the y-intercept, I simply substitute 0 for x in the original function. And of course, any term with an x to any power shall become 0. So this term is neglected, this term as well, and all that remains is the 5. Hence, the y-intercept of the graph lies at y equals 5. So this is the y-intercept. Next, I'm required to find f dash of x. So the derivative of negative x power 4 becomes negative 4x power 3, and the derivative of ax squared becomes 2ax, and the 5 of course is neglected during differentiation because it's a constant. You are then told it is known that at the point where x equals 2, the tangent to the graph of y equals f of x is horizontal. So this is a very important piece of information. A horizontal tangent means that this point is a turning point. The only 3 points on this graph that have horizontal tangents are this maximum point right there, and this maximum point right there, and this minimum point right there. These are the 3 points that have horizontal tangents. So whenever you are told the slope is 0, or the tangent is horizontal, or a horizontal tangent, anything of this sort, you should understand that you are talking about a turning point or a stationary point. And the key feature of stationary points or turning points is that f dash of x equals 0 at these points, because the slope is 0, so f dash of x equals 0. So what we deduce is that when x equals 2, f dash of x shall equal 0. Hence, I plug 2 into f dash of x, which I've done right there, and I equate to 0 because this is a turning point. I solve for a, and it turns out that a is in fact equal to 8. So now that I've shown that a equals 8, I'm required to find f of 2, which is found simply by plugging 2 into this equation and solving manually, or using the GDC as follows. So I've written down my equation on the GDC, substituting a for 8. There is my window for your reference, and there is what the function looks like. So to find f of 2, I press on second, trace, value, and I insert 2, and the calculator tells me that f of 2 is 21. So that's your answer to C double I. Next, you are told that there are two other points on the graph of y equals f of x at which the tangent is horizontal. Write down the x coordinates of these 2 points. So here is something for your benefit. Of course, we know that the turning point referred to previously exists when x equals 2. So obviously it has to be this point. This is the only point where it is possible that x equals 2. So where are the other 2 points? There and there. Without even using the calculator or making any calculations, you can easily deduce that this is x equals negative 2 from the symmetry of the graph, and this is obviously 0 because it's on the y-axis. So the answer to di is just negative 2, negative 2 and 0, two different x values. Not negative 2, 0 as in an ordered pair, just negative 2 for x and 0 for x as well. So let's check this out on the GDC. So in case you could not make this deduction on your own, just press second, trace, find minimum value, and there is your minimum, left bound, right bound, and guess. And the minimum exists at x equals 0. So one of your solutions is x equals 0. Then second, trace, find maximum. There is your left bound and your right bound and your guess. So the maximum exists at negative 2. Of course, negative 1.999 is just negative 2. And the reason why it's not written as negative 2 has to do with the functionality of the calculator. The accurate answer is negative 2. Next, you are required to find the intervals where the gradient of the graph of y equals f of x is positive. So the gradient is positive when the function is increasing, and the function is increasing in 2 intervals. The first interval has no beginning and it ends at this point right there, which is x equals negative 2. Hence, for x less than negative 2, the function is increasing. And since we don't have limits to the function, so there is no lower limit. It's just x less than negative 2. And then the second interval begins at x equals 0 and ends at x equals 2. So for 0 less than x less than 2, the function is increasing, hence the slope is positive. Bear in mind that in all of these intervals, I cannot say less than or equal, I have to say less than. Because at these points, the function is neither increasing nor decreasing, because these are turning points. The slope is neither positive nor negative. So take a look at the answers that we've reached so far. We said that the points exist at negative 2 or 0, and the intervals are as follows. Next, we want the range of f of x, and the range of y values has to do with the maximum and the minimum. So the maximum y value exists right there, and there is no minimum because the function extends indefinitely. So y is less than or equal this value right there, and this value has already been obtained in C"I because this is f of 2, because we said that x equals 2 at the maximum point, so y equals f of 2. Hence, the function exists for all values less than or equal to the value I found here. Hence, y is less than or equal to 21 from C"I. Next, I'm told write down the number of possible solutions to the equation f of x equals 5. So f of x equals 5 is an equation where two different functions are equated. Hence, the number of solutions to the equation has to do with the number of intersection points between the two graphs. The graph of y equals f of x, which is this graph right there, and the graph of y equals 5, which is a horizontal line that cuts the y-axis at the value of 5. And we know that the y value of 5 exists at this point right there. So we are going to draw y equals 5. Excuse me, let's do this again. We are going to draw y equals 5, barely touching the curve at y equals 5. So how many solutions are there? Since there are 3 intersection points there, and this point which we've already identified, and this point, hence there are 3 solutions to the equation f of x equals 5. So again, the number of possible solutions has to do with the number of intersection points. And the number of intersection points is determined from the graph, of course. And if you did not know that the tangent should be drawn right there, you could have used the GDC to make sure as follows. So I'm just going to add the line y equals 5 right there. And there it is. So from the GDC, if you could not infer this, you can just do it on the GDC. So we can tell that there are 3 intersection points between the horizontal line and the graph. Hence, there are 3 possible solutions to this equation. Next, we have question G, which says the equation f of x equals m, where m belongs to R, has 4 solutions. Find the possible values of m. Again, this has to do with the same concept. The word 4 solutions means we are talking about 4 intersection points. So which lines can I draw in this graph or on this graph such that there are 4 intersection points between the line and the graph? So let's try a couple of lines. If I draw a horizontal line right there, there are 2 intersection points with the graph. There and there. Let's try another one. So if I draw a line right there, maybe there are 4 intersection points. So that works. There and there and there and there. So there are 4 intersection points. So let's try a third line, maybe a little bit on top. So somewhere here maybe. How many intersection points are there? There is 1, there is the other, there is the third, and there is the fourth. So we want to know the region, the possible values, such that there are 4 intersection points. So the possible values of y, such that there are 4 intersection points, or the possible values of m, where y equals m is the equation of the horizontal line we're talking about, has to do with the number of intersection points with the graph. So for what region of y values shall there be 4 intersection points? Any region above this line, not including this line, because this line cuts the curve 3 times, not 4 times. We have already determined this in f. This line, which is y equals 5, cuts the curve 3 times. And this line right there, which is y equals 21, because we know from before that this point has a y value of 21 from C double I. So this line on top intersects the curve 2 times. However, any line between the two red lines shall cut the curve 4 times. So any line from the blue lines that I'm drawing shall cut the curve 4 times. Hence, the possible values of y for which the line would cut the curve 4 times exists from 5 to 21. So 5 is less than y, less than 21, or 5 is less than m, less than 21. Not less than or equal, because equal indicates the red lines, which we have already indicated do not intersect the curve 4 times. So this is a bit challenging, I understand, but the good news is that there are only 3 marks allotted to F and G. So take a minute to write the answers down if you will. I hope you have found this useful.